How can you easily deploy your containerized .NET applications into Azure? One of the options that you should consider is using Azure Container Apps, and that is exactly what I'm going to show you in this video. Now, as a bonus, I'm also going to demonstrate how you can automate this deployment using GitHub Actions. Hey, my name is Milan, I'm a software architect and Microsoft MVP, and if you're new to this channel and want to learn more about .NET, you have come to the right place. Now, let's jump into Azure Container Apps. So what is the Azure Container Apps service? It's one of the many services in Azure that allows you to work with containers. Another popular option is Azure Container Instances. There is also the Azure App Service, but what makes Azure Container Apps special is that this is a managed service. So why should you care about this service? What are the problems that it solves for you so that you don't have to worry about them? As I mentioned, Azure Container Apps are a managed service. This means that this is a serverless platform where you don't have to worry about provisioning the underlying infrastructure. You only care about deploying your applications as Docker containers, and then Azure takes care of provisioning what you need to run those applications. Azure Container Apps also take care of orchestration of your containers, which is pretty similar to what you get with the Azure Kubernetes service, but Azure Container Apps are far simpler to work with. Another feature that I wanted to mention is the dynamic scaling capability, which allows Azure Container Apps to scale based on the load on your system. Now, this load could be incoming HTTP requests, it could be the amount of events you're consuming. It doesn't matter. What is important is that you can scale your system up or down based on the current demand. And another feature that you will find useful is Scale to Zero, which allows Azure Container Apps to scale down to 0 instances when there is no load on the system. This also incurs some startup time when you are scaling from 0 to 1 containers, but you're going to see this when I jump into the demonstration. It's also relatively simple to integrate Azure Container Apps into your CI/CD pipelines. I'm going to show you how you can do this with GitHub Actions, but let's not get ahead of ourselves and let's start by manually deploying our .NET application into an Azure Container App instance. So this is a .NET 8 Web API that's integrating with the JSON placeholder API to expose a couple of API endpoints. So we have an endpoint for fetching a list of posts, a post by ID, creating a post, updating a post, and deleting a post. And we have a commented out endpoint that's going to come in handy later when we are going to tackle automating our deployment. We also have a Docker file, and this is the base Docker file that you can scaffold directly from Visual Studio. It's going to take care of some initial setup, building our application, publishing the application, and then exposing an entry point from the application that we just published. So this is the simplest possible approach where we have just one web API. If we had multiple projects, we would also include them inside of this Docker file. And this is what we are going to build and deploy to Azure Container Apps. Now, in order to be able to deploy from our container image, we first need to create a place where we can store those images. And inside of Azure, this is the Azure Container Registry service. So we will have to start by creating our Azure Container Registry. So you can do that by navigating to the Container Registries service. I already have a test container from earlier, but I'm going to walk you through creating a new one completely from scratch. So I'm going to click on Create, and you should see this window where you can choose your subscription and your resource group. I'm going to take an existing one that I already have, and then you need to assign a unique name to your Azure Container Registry instance. Now I'm going to try to specify refit API here, and let's see if it's available. You will see a check mark here if it is. The location is going to be the same as my resource group. I'm not going to change anything. And then I'm just going to scale down the pricing plan into basic because this is just a demo application. Now let's move into networking, and you will see that some of these options are only available when you choose the premium pricing plan. The same goes for the encryption. We're going to skip the tags. And here I'm going to just click Create, and this is going to create our Azure Container Registry instance. You will be navigated into the deployment screen, and this might take a few minutes, so have some patience. And after a few moments, your deployment should be complete, and you can navigate into your resource. So this is the Container Registry instance that is going to hold our container images. Right now, we don't have any images, so let's go ahead and fix that. And we're going to do this by publishing the image for the Refit API project directly from Visual Studio. So I first want to show you the manual approach to achieve this, and later we're going to tackle the automation. So I'm going to click Publish on my web API, and then I'm going to choose Docker Container Registry as my publish target. When I click Next, I'm going to choose Azure Container Registry, and then assuming that you are already authenticated with Azure, you will be able to see your resource group and the respective Azure Container Registry instances. Now I'm going to choose the Refit API one, which we just created, and click Next. And the last step here is how you want to build your container image. I'm going to do that using the Docker file that we have here. So this is the option that I'm going to choose, and let's click Finish. And this is going to create a respective publish profile for us. So let's click Close. And then from here, I can click Publish. And this is going to now build my Docker image using the Docker file that we have inside of this project, and it's going to publish my container image into the Azure Container Registry instance. Now this might take a few moments, but you can see that it actually completed pretty quickly. And I have a message here saying that it successfully pushed the Docker image with the tag of latest. Now let's go back into the Azure portal. This is our container registry, and if I go into the repositories, I should be able to see the Refit API repository. And this essentially represents one Docker image inside of my container registry. Now it's a bit unfortunate that the repository and the container registry name are the same, but this is something that we can live with. But you can see that we have our container image here with the tag of latest that we have just published from Visual Studio. So now that we have our Docker image inside of Azure, we can go ahead and use it to deploy an Azure Container App. Another thing that I recommend that you do to make things easier is enable administrator accounts. So if you go into settings and access key and enable an admin user, it's going to make our job easier when we want to deploy this from Azure Container Apps. If I go ahead and check this checkbox, it's going to generate an admin user with a username and some passwords, but a more secure way would be to create a managed identity. However, for the sake of simplicity, I'm going to use this approach. So I'm going to keep this tab open, and in another tab I'm going to open up the Container App Service. So let's go ahead and open that. I also have an existing application from my testing, but I'm going to go ahead and create a new one to walk you through what this process will look like. So again, I'm going to choose the subscription and the resource group, and let's give my container app a name. So I'm going to pick Refit API. So I just want everything to match the name of my container, and then the deployment source is going to be a container image. We're going to choose which image exactly a bit later. The next thing that you can configure is the container app environment, and I'm going to use the same region as my resource plan, and I'm going to use the default environment here. Now the next step is actually choosing our container instance. If you don't have a container image already, you can use the quick start image to validate your deployment. But in our case, I'm going to use the container image that I already built and published to container registry. So here I'm going to choose the image source as Azure Container Registry, and then I'm going to pick the correct Azure Container Registry instance. So this is going to be this one here. Then I can choose my image, which is Refit API, and then I'm going to choose the tag of latest. As far as the other options here go, I'm going to leave everything with default. The interesting aspect here is choosing your resource allocation. The consumption plan is the serverless approach that allows you to use up to 4 cores and 8 gigabytes of memory for your containers, and then you can decide how much one container is going to consume. So I'm going to choose half a CPU core and 1 gigabyte of memory. You can also specify your environment variables. So let's go ahead and specify the ASP.NET Core environment. And then for the value, I'm going to choose development. And I'm just adding this so that we can see the Swagger user interface when we deploy this application. Now, the next step is the bindings, where we don't have to do anything, but I'm going to go back to the previous step for just a moment. And I wanted to mention that the environment variables is a perfect spot where you can specify your connection strings. Another approach would be to use Azure App Configuration, and you will have to configure the access from your Azure Container App, or you can also use Azure Secrets if you want a more secure approach. Now I'm going to move into the Ingress tab, where I'm going to click Enabled, and this is going to allow me to expose my container to the outside world. And I'm going to choose accepting traffic from anywhere over HTTP, and the other options I'm going to leave as default. So I'm happy with this. Now my container will be accessible, and because this is a web API, we'll be able to call the API endpoints. I'm going to now create my container app, and this is going to take a few minutes. So I'm going to wait for this to complete, and you're going to see the finished result. And after a few minutes, my Azure Container App is deployed, and I can go to the resource. When you open your Container App, you have access to many of the familiar Azure options from the Overview tab. Here, you can also see some useful info. Now, what we are interested in is the application URL here, which is going to allow us to access our application. So if I open it, I won't be able to see anything because I don't have anything on the default address. But if I navigate to Swagger, we will be able to see the Swagger UI because I have exposed it with the proper environment variable. And if I call an API endpoint with some user ID, you will see that we are getting a response back. I can also go ahead and fetch a post with a specific ID, and you can see that the API is working. Now let me go back to the Container App where I want to show you another thing. If I go into the Containers tab, we can see more details about the actual container that we are currently running, what is the resource allocation, what are the environment variables, and some other things. If I go into the revisions, I can go ahead and see the actual deployment that is currently active. If there is another revision, it's going to show up here until it replaces the current one when that one becomes inactive. You're going to see this when we actually deploy a new version of the application. Now, what's also cool here is that this revision of our container is currently handling 100% of the incoming traffic, which makes sense because this is the only container that we have. But what you can do here is do traffic splitting. So you can have multiple revisions active inside of your container app instance, and you can split the traffic between these containers. This is useful if you want to do blue-green deployment or A/B testing of some features. So this is an advanced feature that you have access to with Azure Container Apps. Now, if I wanted to change something, I can go ahead and click Create New Revision directly from the Azure portal, and I can choose if I want to change some things. For example, I may want to scale my application to have a minimum number of replicas. Let's say the minimum replicas should be 2, and currently the maximum number of replicas is 10, and you can even scale this out to 1,000 replicas here, and you can scale this out to as much as you need to. If you want some fine-grained control, you can define a scaling rule here by clicking Add, and this will allow you to create a scaling rule, so you can either scale based on incoming HTTP traffic, based on Azure Queue consumption, or if you want, you can create a completely custom rule. Now, I'm not going to be going into this, so I'm going to close this down. What I do want to show you is how we can automate this entire process using GitHub Actions. I'm going to walk you through the GitHub Action workflow file that we're going to use to deploy our .NET application into our Azure Container App instance. Now, if you aren't familiar with GitHub Actions, I'm going to leave a beginner-friendly video in the description that you can watch first, and then you can come back to this video. However, I'm also going to keep this explanation extremely simple, so even if you aren't familiar, I think you will be able to follow through. The first section here defines how we are going to trigger our GitHub action, and this is either a workflow dispatch, which means we can manually trigger the action, or we are going to trigger this on a push to the main branch. Then I have a few environment variables for the Azure Container Registry name, the container app name, and the resource group name. And then we have the actually important part of the GitHub action, which is the build and deploy job. This job consists of a few steps. The first step is the checkout action, which is going to check out our repository. Then we're going to set up the .NET with version 8. Then I'm going to build my application, and this is just a precaution measure because I don't want to continue if I can't even build the project. Then I'm going to set up the Docker buildx action, and I'm going to attempt to log in to Azure Container Registry. And here, I'm going to use the Azure Container Registry environment variable, but I'm also going to specify some secret values using GitHub secrets. And these are going to be my Azure Container Registry username and password. I'm going to show you how you can get these values and how to configure them inside of your repository. After we complete the Docker login command, we're going to build and push our container image into Azure Container Registry. I'm specifying the path to my Docker file here. The push flag is set to true, which means after we build it, we're also going to push this image, and then you can customize how you want to tag your container image. I'm going to specify the fully qualified path of my image, which is the Azure Container Registry name, then azurecr.io, and then I'm going to specify my container app name, and I'm going to tag this with a hash of the current commit. So this is how I'm going to tag my container image. And then after we push this to Azure Container Registry, we're going to log in to Azure using the CLI. We're going to log in to Azure using the Azure login action, and we are going to need the Azure credentials, which is going to be another secret. I'm also going to show you how you can obtain this value. And the final step here is using the Azure Container Apps deploy action, where we are actually going to deploy our .NET application into the Azure Container App instance. We have a couple of arguments. The first one is which image we want to deploy, and you're just going to specify the image with the respective tag as we have in our build and push step. The resource group and the container app name are going to come from the environment variables, and then you can specify any custom environment variables that you want. You can also pull these values from your repository secrets. So let's go ahead and set up the secrets that we are going to need for this action to complete successfully. This is my repository where the source code is hosted, and if I go into settings and then secrets and variables and then choose actions, I can choose between repository secrets, which I'm going to use, but what's also interesting is you can use environment secrets, and this allows you to specify different values for different deployment environments. So you can customize your deployment through GitHub Actions using specific environments. In order to keep this simple, I'm just going to be using repository secrets because we only have one environment. So let's choose new repository secret, and then for the secret name, I'm going to choose Azure Registry username. We have to jump into the Azure portal to find this value, and if you go into the access keys for your container registry, the username you will find here. If you configured a managed identity for this, then you will have to use that. So I'm going to paste in the secret value here and create my secret, and then I'm going to create another secret. This one is going to be the Azure Registry password, and you can also get this value from the Azure portal. And then I'm going to add the secret. And then the last secret that I need is going to be my Azure credentials. And you can get this value by creating a service principal, which is a secret value that allows you to authenticate with Azure. And I'm going to create this using the Azure CLI. So this is the command AZ-AD and then SP, which is short for service principal. AD is for Active Directory. Then I'm going to specify create for RBAC, which is role-based access control. The name of my service principal is going to be Refit API. The role is going to be contributor, and I'm going to scope this to my current subscription. And then I'm going to click enter. And if you're authenticated with the Azure CLI, this is going to create a service principal. And the service principal is just a JSON object that you're going to copy and store as a secret value. And we're going to paste the secret value into our GitHub secrets. So let's go ahead and create this. And now let's go ahead and update the environment variables in my GitHub action workflow file. So I have to assign the name to the Azure Container Registry, which is just Refit. The container app name is also Refit, and the resource group name is YouTube. And now I have to push this into my repository, and it's going to trigger this action. If I open up the Actions tab, assuming I did everything correctly, I should see my GitHub action executing here, and I will be able to navigate into it. I can go into the build and deploy job, which is the only job that I have, and then we can follow these steps inside of our job. So currently we are setting up Docker, and the beauty of demonstrating something like this live is, of course, it's going to fail. So my first try of running this GitHub action failed because I specified the incorrect environment variables for the container registry name and the container app name. It's actually Refit API. So now that I fixed that, I should see this go through to completion. Right now, we are building our Docker image, and after we build it, we are going to push this image into the Azure Container Registry. So you can see that this step completed. Now we are authenticating with Azure, this also completed, and now we are deploying our Azure Container App based on the image that we have just built. This step is going to take a few moments, so we're going to wait it out until it completes, and after a few moments you will see that my GitHub action completed successfully. Now let's jump into the Azure portal. What you're seeing here is my Azure Container App instance, where you can see the two revisions. We have the previous revision that we manually deployed, and then here is the new one that we deployed through GitHub Actions. And right now, the old revision is deprovisioning, and all of the traffic is routed to our new revision. So I should be able to go into the Swagger UI and refresh, and everything should be working as before. Let me confirm that I can fetch the posts. So our API is still working. So if I refresh this, we should only see our one revision. If I check out the containers that we have, you can see that the tag of our container contains the commit hash that we picked up from Git. Also, if I go into my repositories in the Refit API container registry, you can see that we have multiple versions of our image. We have the latest image, which is no longer latest because this was the one that we pushed from Visual Studio. The latest one is this one that we pushed from our GitHub action. Now let's head back to Visual Studio, where I'm going to uncomment this piece of code because I want to make a change to my application. And now let's go ahead and commit this change and see if we are able to successfully deploy it. So I just added a commit for creating my new API endpoint that's going to allow me to fetch the comments for a given post. You can see our GitHub action is executing right now, and it takes about a minute and a half, sometimes 2 minutes to complete. So I'm going to wait this out, and then if this completes successfully, I'm going to show you what the updates look like inside of the Azure portal. So you can see that my GitHub action completed in about 2 minutes and 12 seconds. If I jump into my container app, you can see that my new container instance is already up and running and serving 100% of the traffic, and the old container image is deprovisioning. And if I go into the Swagger UI and hit refresh, you will see that our new API endpoint is showing up, which means that our deployment was successful, and I'm able to send a request to this endpoint and get a response back. So now we are sure that our automated deployment is working as expected. And if you enjoyed this so far, then make sure to smash the like button under this video. So this was an example of how to deploy your .NET application into Azure Container Apps and how to automate this deployment with GitHub Actions. If you enjoyed this, then make sure to click the like button below. If you want to learn more about working with GitHub Actions, then you should watch this video next. Check out my clean architecture and modular monolith courses to improve your skills, and until next time, stay awesome.